Okay. Okay, so quadratic function, ax squared plus bx plus c, where a cannot be 0. The graph of a quadratic function is called a parabola. It is always a cup-shaped curve. It opens upward if a is greater than 0, or opens downward if a is less than 0. So you've talked about these things in algebra. That should not be anything new. Okay, that turning point on a parabola, which is also going to be the lowest or the highest point on the parabola, depending on which way it opens, is called a vertex. And it's an important point on the parabola because it is either that maximum or minimum point. The x-coordinate of a parabola can always be found by taking negative b and dividing by 2a. What are b and a? The coefficients here in front of the x squared or the x term. The vertical line x equals that number is the line of symmetry, although it is not part of the graph. Okay, so tell me, how would you go about graphing this? No instructions, I said graph this. What would you do? Pardon me? Okay, let's find the vertex. And then we may cheat a little bit and well, no, we're not going to cheat. But we could. I'll show you how in a second. All right, but I would definitely find the vertex. Can I just use my calculator and find some ordered pairs for the vertex? Yes, if the vertex is at an integer. But what if the vertex is like -1/2, 8? The table's going to skip over that point. So sometimes just typing it in your calculator won't find the vertex for you. So this is a good formula to know. So let's find the x value. Okay, negative is out front. You can just also associate it with the b value. What is my b value here? -2. A is what? 1. And then this, of course, is c. Okay, so I'm going to say the opposite of b over 2 times a. Okay, well, that negative times the negative is going to become a positive. So the x-coordinate is 2 over 2, which is 1. Okay, so that's a nice simple vertex coordinate. How do I find the y-coordinate? That's the x-coordinate of the vertex. How do I find the y? Sub it in. So I have to find f of 1. So that's 1 squared minus 2 times 1 minus 3 is 1 minus 2 minus 3 is -1 minus 3, which is -4. So my vertex is the ordered pair 1, -4. Okay, 1, 2, 3, 4. Let's plot that on the graph. Does this parabola open up or down? Go back to here. Opens up if a is greater than 0. Opens down if a is less than 0. What is our a? +1. So this will open upward. Okay, let's use our calculator now to get a few other ordered pairs so that we can pretty easily graph a simple function. Okay, so I'm using a little one. You can also do the big calculator. I'll show you that one. Everybody grab a calculator, whatever kind you want to use. Small or graphing, doesn't matter. I'll show you how to get the ordered pairs either way. Okay, so if we're using this small calculator, we're going to go to table and type in our function, x squared minus 2x minus 3. Ooh, no. What happened? 2x, there we go, minus 3. And then just keep pushing enter until we get a nice little table of values. Okay, if you're on the graphing calculator, you're going to have to go to y equals. Okay, if you got other junk in there, you got to clear it out. Okay, now we're going to type in x squared minus 2x minus 3. And for the graphing calculator, see where it says table, which is above the graph key? We're going to access that table. So we're going to push second graph, and there you should find some ordered pairs. Does anybody have anything really wonky in their table? Okay, so whichever calculator you're using, just pick a few. Let's see, I'm going to use that one. 1, -4, 2, -3. Okay, and then connect them. Okay, so what is this line of symmetry for this particular parabola? It's the line that cuts through the middle of the parabola, right? It's not part of the parabola, but it helps define the points on the parabola. So it's this line that splits right through the parabola. Isn't it always going to go through the vertex? Yeah, and a vertical line is always of the form x equals some number. Well, what does x equal? Go back and look at your vertex. X was 1, so x equals 1 is that axis of symmetry. Question? Alrighty. Next. Okay, let's find the x coordinate here. So what was that formula again? X equals what? Negative b over 2a. Okay, what is b? Negative 10. So negative 10 over 2a. A is negative 2. Sub that in. So that gives me 10 over negative 4, or negative 5 halves. Or if I'm graphing, I don't really want to think of it as negative 5 halves. I want to think of it as what? Negative 2.5. That's easier for me to graph than negative 5 halves. Okay, so this is a situation where strictly going to your calculator, your table would skip over that vertex point if it's using integers, because that's not an integer. Okay, so now to find the y coordinate, we are subbing in negative 2.5 into the function. Okay, you set it up, I'll set it up, but I'm not going to talk through it. And then we'll compare. Parentheses are important on this one. Check up here and see if you got the same thing I got when you're finished. Did we get the same? Okay, if we didn't, then we need to check parentheses. The parentheses around that negative 2.5 being squared are crucial. Everybody good? Okay, so now we can plot that. Of course, we just have to estimate where that is. So negative 2.5 and then 7.5. Kind of right in that box right there. Not going to be on crosshairs, is it? Does this parabola open up or down?
Down.
Down, because that a coefficient is negative. Now I will go to my calculator. type in the function and get some other ordered pairs that we can find on this. Okay, 1, 2, 3. Okay, so I've plotted these points here, and I know if that's the vertex, that's the center of the parabola. So I need to go on my table and get some more points over here. Continuing to go this way will be useless. So let's go get some negative coordinates. -1, 3. I got that. -2, 7. Alright, so this one's pretty narrow. What made this narrow? What made it skinny? This one's skinnier than that one. Just because? What made this narrow? The 2. The 2 in front is like a vertical stretch, so it makes it more narrow than the previous parabola. If I had a coefficient of 5, it'd be even more narrow. What would make it wide? Like a 1/5 or 1/2.
40%.
Yeah. Yeah, that's good. Okay, y'all look over your quadratic formula, which you should be. Andrew, what'd you get? First of all, did you move the 2 over and set it equal to 0? Okay. Because notice, before we use the quadratic formula, that equation needs to be equal to 0. So I'm going to do this. I'm going to say -2 equals 0. Okay, voila, the 2 is moved. Okay, so let me set it up super quick here because we have some disagreement on what we're getting. Okay, so B is a -4. So I always like to think of that negative out front as the opposite of B. So if I'm taking the opposite of -4, yes, that's going to become a +4. Plus or minus the square root of B squared minus 4AC all over 2 times A. Okay, so let's see what we get. We get a +4 there. I get a 16. Negative times negative is positive. 12 times 2 is 24 over 6. Okay, 4 plus or minus 40 over 6. Okay, so 40 can be simplified because 4 divides into it. So this is the square root of 4 times 10, but the square root of 4 is 2. So I get 4 plus or minus 2 square root 10 over 6. Then 4, 2, and 6 are all divisible by 2. So that reduces to 2 plus or minus square root 10 over 3. Okay, if you made a mistake, did you find it? Do you understand what happened, and did you correct it? Any questions on any piece of that? This is what I don't advise. A lot of times people will set that up and then they grab their calculator. Please don't do that. Grab your calculator only to figure out this number underneath the radical to find the 40 and then simplify. Okay? Any questions on that one? Who got it right? Brag on yourself. Okay? Who made a dumb mistake? We all do it. We all do it. Except Jesse, who's not here. I'm sure he never does it. He's on the video, so we can make jabs at him. Or he's hopefully going to watch the video. Let's say that. Huh?
Did you start recording?
Mm-hmm. Okay, so let's do this one. 100% right this time. Yes? I'm going to work it out, but I'm not going to talk through it. We've got to subtract that 7, right? Let's do our little magic move here. Minus 7 equals 0. We moved it. Okay, here we go. Okay, check up here when you're done. Any questions? Are we good? Andrew, you good?
Yes, sir.
Okay. All right. Okay, what if we got a negative under there?
Is that impossible? Is that not? I thought that was something like
It's possible, but it'd be what kind of number?
I.
Yeah, we'd have an I involved, which means it'd be an imaginary number. Okay, we generally are not going to be involved in those in here. Calculus, we deal with real numbers. So, not that it would be wrong necessarily, but generally we're just going to have positives under there. Okay, polynomial function. Oh,
That gives me flashbacks.
yeah, look at this. A sub n x to the n plus a sub n minus 1 x to the n minus 1 plus all the way down to a sub 2 x squared plus a sub 1 x to the 1 plus a sub 0. Is that clear?
Sure.
Where n is a non-negative integer and all of these a sub things are real numbers called coefficients. Okay, don't let this fancy notation scare you. It just means that you have a bunch of exponents on your variables. If it starts with x to the 8, then this will be x to the 7, x to the 6, x to the 5, all the way down to x squared, x to the 1, and then just a constant, just a number. So it just means you have exponents that are bigger than 1. Okay, so something as simple as x squared, that is a polynomial. Now, it's a kind of a specialized polynomial. We call it a quadratic. This is a cubic, but they're actually both polynomials. Okay, just very simple polynomials. Okay, so use the same set of axes, graph x squared and x cubed. So if you have, if you have two colors, you might want to use that. Borrow mine if you want, or if not two colors, then we'll just label each one of them. Okay, so can I just sketch a parabola like somewhere? let's get some exact points, and we could probably do these pretty easily in our head. What if I sub in 0 for x? What do I get for y? 0. What if I sub in 1 for x? I'm still just dealing with the x squared. 1. What if I sub in 2? 4. 1, 2, 3, 4. Okay, should I keep going to the right here? We know this is going to be a parabola. This is going up. Let's get some points to the left. So if I sub in -1 and I square it, I get +1. If I sub in -2 and I square it, then I get +4. So you can also put that in your calculator if you want to get some exact points. Okay, it's just so easy to get a few exact ones and make it look accurate. Okay, so that's our x squared. I'm just going to label it with f of x, or you can label it as x squared, or you could label it y equals x squared. I'm just going to give it its name of f. Okay, now I'm going to graph x cubed. Okay, we can get a few points in our head pretty quickly. If I sub in 0, 0 cubed is 0. If I cube 1, what do I get? 1. Is it the same graph? What if I cube 2? 8. 1, 2, 3, 4, 5, 6, 7. Ooh, barely. Okay, if I cube 3, that's going to be 27. That's going to be way up the page. Okay, so what about -1 cubed? -1 times -1 times -1 is -1. Okay. What is -2 cubed? -8. Oh, why does that one not go to 8? That's strange. Okay, so is it a line maybe? No. There we go. That is our cube function, or I'm just going to label that g of x. Okay, if it was more complicated, then I'd probably type it in my calculator and get a few exact ordered pairs. Can you wait a second? Okay, functions given by the quotient or ratio of two polynomials are called rational functions. Okay, here's our parent function of a rational function. Anytime you hear rational in math, think fraction. So what does this thing look like? That was one of the main ones that I talked about at the beginning of the semester. Hyperbola. There are actually two parts to it. Okay, let's see what some ordered pairs are here. Go to your table, whichever calculator you're going to use, and let's type in 1 over x and see what these exact points look like. See a bunch of fractions, don't we? Okay, so let's plot a few. -4, -1, just pick some. You might have different ones that are showing up first, but plot a few. It's kind of hard to plot some of these, isn't it? So if I plot the ones that I see in my table, it looks like I've just maybe made a mistake. Like, that doesn't tell me much of anything, does it? Okay, so how do we get those other points that I showed you the graph looked like? All right, so if you look on your table and you go from 1 to -1, you have error at 0. Okay, why do I have an error at 0? Well, because can I divide by 0? No, if I sub 0 into this function, it's undefined. So it's trying to tell us, hey, that's undefined there. So I have no point between here and here. Well, that's not true. Like, what if I had 1/2? Okay, let's just go to a blank screen here, and I'm going to put 1 over 0.5. That's 2. Okay, so I have this ordered pair 1/2, 2. Now you kind of start to see the curve of this thing. Okay, so what if I used 1/3? 1 over 1/3 is 3. Okay, so if I go over 1/3, then I'm going up 3. Now you can really start to see the curve of it. Okay, so that's where we get this. I mean, it's kind of like a really wide parabola, but it's not. But it kind of has a similar shape to it. And then the same thing over here. If I just made this negative 1/2, then that would give me negative 2. If I made this negative 1/3, it would give me negative 3. So I've got the same thing going on over here that gets me this second portion of that curve. Okay, so if I'm looking at a table of values, I can't use 0 because that's undefined. Okay, is there some number of x that will give me 0 for y? Can I take 1 and divide it by something and get 0? No, that's not possible. So there's no value that corresponds with y being 0 either. Okay, so actually what we have on here is 2 asymptotes. One being on the y-axis and the other one is on the x-axis.
That's what that's I thought it was like they never touched that.
Yep. So both axes are like boundaries that sort of contain the curves. And they're not touching the x or the y-axis because these situations aren't possible. There's no value that I can sub in for x to get y of 0, and I can't sub in x of 0 because that's undefined. So that's what's creating these 2 asymptotes, just this impossible situation there. Okay, so y varies inversely with x if there is some positive number k for which y equals k over x. We also say that y is inversely proportional to x. Okay, so k is just representing a number here. This is where k is 1. Okay, so if I had 2 over x, 3 over x, 5 over x, negative 8 over x, etc., this would be describing an inverse variation. Okay, so what is an inverse variation? Okay, look, as I move along this x-axis, x is getting bigger, but what's happening to y? It's getting smaller. As x gets smaller here, closer to 0, what's happening to y? It's getting bigger. So that's an inverse variation. For example, the more you exercise, you increase your hours of exercise, ideally your weight should decrease. That's an inverse situation. One quantity goes up, the other goes down. Okay? All right, let's see. We are going to stop after example 7, and then we'll work on some homework and finish up the notes tomorrow. Okay, example 5. Certain economists theorize that stock prices are inversely proportional to the price of gold. That is, when the price of gold goes up, the prices of stocks go down. And when the price of gold goes down, the prices of stocks go up. Let's assume that the Dow Jones Industrial Average D, an index of the overall price of stock, is inversely proportional to the price of gold G in dollars per ounce. One day, the Dow Jones was 9,177, and the price of gold was $364 per ounce. What will the Dow Jones average be if the price of gold drops to 300? Okay, if this is an inverse proportional situation, then I could use this y equals k over x as like a formula. So if I have y equals k over x, okay, instead of using x and y, I'm going to use the letters D and G that they've used here. So let's flip back just for a second. This says y is inversely proportional to x. So this thing that comes before the is, in word problems, isn't the word is an equal sign? So y equals k over x. Y equals k over x. Y is what's inversely proportional. Okay, so let's flip over here. Stock prices are, that's a form of is, right? So stock is inversely proportional to gold. Okay, our stock was D, is inversely proportional to gold, which is G. So my equation would be D equals K over G. Stock is proportionally, inversely proportional to gold. Now, let's go back to this information. Okay, great. Let's everybody cough. Everybody get it out. All right, let's go back to this information. Dow Jones was 9177 when gold was 364. I'm going to use this information to figure out what K is. How would I solve for K? Multiply by 364. All right, so our K value is not a tiny number. It is 9177. Good gracious. 3340428. Okay, so that's our K value. Now, what we really want to know is what will the Dow Jones be when gold is 300? So I'm going to use this as my formula. Dow is inversely proportional to gold. I'm looking for the Dow price. K I just found. 3340428 over gold. Gold is 300. So let's divide that out, and that will be a prediction of what the Dow price, Dow average will be. Okay, did you get 11,134.76? Okay. Question on that. Okay, let's see. Absolute value function. Okay, so we've graphed this. What does it look like? V. Where's the point of the V if it's just the plain old absolute value? At the origin. Okay. Can I use this to get some ordered pairs? Not the little one, but I could use the big one. I'll show you in a minute, but let's do this mentally for a second because it'll be quicker. What's the absolute value of 1? 1. What's the absolute value of 2? 2. Absolute value of 3? 3. What's the absolute value of negative 1? Positive 1. Absolute value of negative 2 is 2. Absolute value of negative 3 is negative 3. So this is like two pieces of lines. This side has a slope of 1, and this side has a slope of negative 1. Okay, now you could, say it was something really fancy and complex, you could use this calculator to go to y equals, and we do have an absolute value button, not button, but it's in this math menu. Math is over here on the left column. Math, go over to number, and there is our absolute value. and then you could go to the table and find some ordered pairs. Okay, so if it was something more complex, you might want to use your calculator. Do I need to go back through that again? Did I lose anybody on that? Okay. Alrighty. Okay, last one for today. The square root function. So all of these clearly are not lines. That's why they're called nonlinear. Notice that we're going to graph negative square root of x here. What's that going to look like? Yeah, remember, plus or minus square root of x was a sideways parabola. The top portion is square root x. The bottom portion is negative square root x. So it's basically this bottom piece of a sideways parabola. Okay, let's get some ordered pairs, though, and see what's going on. Either calculator. Okay, you'll notice if you go to any of your negative x values, you're going to have an undefined situation. So we're going to start at 0, 0. 1, negative 1. Fraction, fraction, fraction. There's another integer. 4, negative 2. And I don't even think I have room for my next one, which occurs at 9, negative 3. 1, 2, 3, 4, 5, 6, 7, 9, somewhere over there, negative 3. Okay, so that tells you how steep or not steep to make it. And there's the bottom half of our sideways parabola. Question? All right, so I'm going to stop there with the notes. On your agenda, you can start on these. We will be finishing up these notes, so these homework problems will not be due until Friday. Okay? Let me see which ones would be a good idea. That's a good question. Page 64. Okay. I would strongly suggest using the graph paper over there. There are 2 graphs on each side, so you could get 4 graphs on one piece of paper. I may have some other graph paper. I'll check and see, but I think help yourself to those because these are much easier if they're on graph paper. If you have your own graph paper, feel free to use that as well. Let's see. All of those are graphing there. I would stop at maybe I'd maybe stop around here. The bulk of those will be graphing. Okay, and then I'd save those others for tomorrow. Everybody clear on that? Alright, you got loads of time to work on these. I do have a pad of graph paper here. Okay, so grab some graph paper over there, or I'll put this pad of graph paper up here on the table, and you can come and get that if you want just plain old graph paper.